Hey everyone, I hope you're doing well today. In this video, let's simplify down how to solve this SAT or ACT practice problem together. Now, if you'd like to try this problem on your own first, go ahead and pause the video right now. Otherwise, let's go ahead and do it together. The equation of circle Q in the xy plane can be represented by this equation of x squared plus y squared minus 6x plus 8y equals negative 9. The question is, what is the radius of circle Q? To solve this problem, we're going to want to remember the equation of a circle. For the equation of a circle, we have the quantity of x minus h squared plus the quantity of y minus k squared is equal to r squared. X and y represent the coordinates of points along the circle, and the center is denoted by h, k. And on top of that, the radius is just going to be r. Let's take a look at this visually on a coordinate plane now. Here's our x and y axis, and here's a circle with our point in the center. For this particular circle, the center is h units to the right and then k units down. And from the center to a point on the circle, that's going to be the radius. Now that we've reviewed the equation of a circle, let's try this problem now. Since the equation we were given isn't in the form of the equation of a circle, let's see if we can be creative and rearrange it a bit so it does end up looking like that. Let's rearrange these terms so that x's and y's are together. So first we'll have x squared minus 6x, and then we'll have y squared plus 8y. Going ahead and grouping the x terms together and then grouping the y terms together, let's go ahead and do something called completing the square. Basically, we're going to add some constant into the first grouping with the x's, then another constant to the grouping with the y's, and to keep the equation balanced, let's go ahead and add both of those constants to the right side as well. To figure out what constant to add, you're always going to take half of the b term of the quadratic, or half of negative 6, and that's going to be negative 3, and squaring negative 3, we're going to get positive 9. With that, we're going to add 9 to both sides of the equation. Similarly, with the y terms, we're going to take half of the b term, which is half of 8, and that's going to be 4 squared, and that's going to equal 16. We're going to go ahead and add 16 to both sides of the equation. Now that we've completed the square for the x terms and the y terms, then we technically have two perfect square trinomials. Factoring this x squared minus 6x plus 9, we're going to get the quantity of x minus 3 squared, and factoring the y squared plus 8y plus 16, we're going to get the quantity of y plus 4 squared. And over to the right side of the equation, negative 9 plus 16 equals 16. Basically, we needed to complete the square so that we could rewrite the original equation we were given in the form of the equation of a circle. Now let's go ahead and compare what we got to the standard form of the equation of a circle. Now that we can see that everything is lined up, we can see that h is equal to 3 and k is equal to negative 4. Based on this, we know that the center of the circle is located at 3, negative 4 in quadrant 4. And on the right side, we know that this 16 has to equal r squared, so taking the square root of both sides, we know that r, or the radius, is equal to 4. Therefore, we can answer this question by saying that the radius of circle Q is equal to 4 units long. Hopefully this video gave you a little bit of a refresher on circles, and you'll be able to tackle a problem like this in the future, no problem. As always, keep up the great work, and I'll see you in the next one.